Hi everyone, this video is for my Module 3 lecture for CIT 247. Some of the topics I'm going to be discussing today are VLANs, trunking, and then I will end the video with a VLAN demonstration. Now, before I begin, I want to say that my first two lectures didn't really have a lot of practical stuff where I was demonstrating how to actually implement the topics you're learning about. That was mostly because those labs already came with the commands you need. Moving forward, as you'll notice the lab assignments won't include the commands you need most of the time. My lectures here are going to be demonstrations of the topics you'll be learning about. They will still have PowerPoint slides, and I'll go over some basic details and some more difficult details you need to understand concerning your topics for each module. But these videos from here on out are going to mostly be used for practical demonstrations. So let's begin by discussing VLANs. So VLANs are basically virtual local area networks, or virtual LANs, thus the name, that are used to separate a switch into multiple broadcast domains or LANs. Now I'll show that in a picture here in a moment, but basically the idea behind VLANs is that sometimes you want to separate a switch into multiple broadcast domains or local area networks. Now there's multiple reasons for doing that. One of them is security, as you'll see here in a minute, but also it can actually improve performance as well. When you have less broadcast domains, you actually increase the performance because you actually when broadcast well, I mean it increases performance because when broadcast frames are sent out, the switch sends it to less hosts. So basically, a broadcast frame is basically contained within a single VLAN, and thus is sent to less devices. So when VLANs are used, certain ports on the switch are assigned to a particular VLAN. So for example, if you had a switch and you created VLAN, let's actually change it to VLAN 10. If you had like VLAN 10, you could apply ports FA0 to FA03, and you would have 4 points or four ports assigned to that VLAN. VLANs also follow many of the same rules that apply to LANs. For example, all devices in a VLAN are in the same broadcast domain. And in a sense, a VLAN, a LAN, and a broadcast domain are pretty much the same thing, except a VLAN is actually a virtual LAN. It basically, instead of like having a physical switch and physical computers comprising of a LAN, a VLAN allows you to create virtual separations or virtual divisions in a physical LAN and create multiple virtual broadcast domains. So each VLAN should have its own subnet, similar to the concept I talked about earlier or in a previous module about LANs. All devices in a LAN need to be in the same subnet. If they aren't, they can't communicate with one another. That's why routers are used to allow devices in different LANs to communicate with one another. But for this lab, we're not going to use that. VLANs, so all the devices in different VLANs will not be able to communicate with one another because they'll need to be in different subnets. So without routing, devices in different VLANs cannot communicate with one another, and that's as I just discussed. So here's an example of a VLAN. So you see this is one physical switch right here that has 6 ports that are named. Excuse me. But notice here the VLAN. So these 2 ports here, FA0/11 and FA0/12, those are all assigned to VLAN 1. So therefore, all these devices here, they're in their own subnet, and they can communicate with one another. However, if this switch is not a multi-layered switch, these devices here cannot communicate with the other VLANs. And you can see here also 2 ports are assigned to these the 2 ports that are assigned to these computers are assigned to VLAN 2, and the 2 ports here connected to these computers are assigned to VLAN 3. So these are 3 separate broadcast domains or LANs, all on the same physical switch. That's the point of VLANs. We break up a physical switch into multiple broadcast domains or LANs. Now, there comes a point where you need to use what's known as trunking. So VLANs, believe it or not, can actually span multiple switches. So you can have like say 2 switches, and you can have like VLAN 10 on each one. However, there becomes a problem when you have multiple VLANs between 2 switches or multiple switches. The switch needs to know how or which VLAN a certain frame is assigned to, or which or which VLAN a certain frame needs to stay in. So that's what trunking is for. So when VLANs span multiple switches, trunking is needed to allow communication between the devices across the switches. Trunking adds extra data called VLAN IDs to frames traveling across switches. These VLAN IDs help switches keep track of which VLAN a frame belongs in. So when implementing trunking, please make sure to use the 802.1q encapsulation protocol. This protocol is applied to the specific ports that connects the two switches. There's actually two types of encapsulation protocols. You probably will hear about that in Rana's lecture, but for this class, you need to use the 802.1q encapsulation protocol. We'll discuss that in a minute, or how to apply in a minute, but let's look over this little diagram here. So these are two switches, two physical switches, and you notice how they have the same VLANs. So VLAN 1 is on both switches, and so is VLAN 2. So if you say a PC here in VLAN 1 on switch 1 needed to talk to this computer in VLAN 1 of switch 2. So you see here in this step-by-step thing here, the PC1 creates a Ethernet frame. The switch sends it through here, but the switch, before it does that, the switch actually creates this VLAN idea and attaches it to the Ethernet frame. And this is a trunking cable right here. You see here it's not assigned to a specific VLAN. That's going to be important for your lab. So trunking cables basically are cables that connect switches to each other, but they're not a part of a specific VLAN. The trunking is basically to send data from one VLAN on a switch to the same VLAN on another switch. So with this VLAN ID, switch 2 sees the frame, it checks the VLAN ID, and it sends that frame to VLAN 1, and specifically to the computer in VLAN 1 that PC1 wanted to talk to. So some points to keep in mind for Lab 3. VLAN 1 is a default VLAN. You really need to create different VLANs for your labs now. VLAN 1, we'll use that a little bit in this course. VLAN 1 typically is used for like assigning an IP address to a switch. VLAN 1 typically is just used as a default VLAN. It's actually what's known as native VLAN. An interesting thing about native VLANs with the 802.1q encapsulation is that devices in VLAN 1 actually don't need the VLAN IDs. So it's called tagging actually. So tagging is not needed for devices in the native VLAN. We're going to be creating new VLANs for our lab, but just keep that in mind about native VLANs in VLAN 1. The ports connecting to PCs are assigned to a certain VLAN. The ports connecting switches are made trunking cables. Please do not assign them to a VLAN. So, in other words, when you're making your VLANs in your lab, make sure the ports that the switch that connects the PCs to a switch are contained within a VLAN. However, the ports connecting switches to each other are configured to be trunking cables. So make sure you don't assign trunking cables to a VLAN. That's not their purpose. Another point to keep in mind is all VLAN ports must be placed in access mode. So basically you have two major modes. Trunking mode, which helps data travel from one switch to another, and then you have access mode. Basically those are access switches, or those are access ports for basically like computers. Trunking is not going to occur on a port that's connected to a computer, and therefore you need to assign it as an access mode. Otherwise you're going to end up confusing the switch. So be sure to check this module's command guide. It provides all the commands you need for the lab. This is actually the command guide right here. I'm going to come back to it in a minute, but this will be posted on Canvas once I finish recording this lecture. So also make sure to use the 802.1q encapsulation for all trunking cables. The way you implement this is through these two commands: switch port trunk encapsulation .1q. You need to make sure you spell it dot and then 1q. You don't spell it 802.1q. Just write .1q. So computers in one VLAN should not be able to contact devices in another. All devices in the same VLAN should be able to communicate with one another. If this is not occurring in your lab, then there is something wrong with your configuration. So if you're having trouble getting devices in the same VLAN to communicate, here's some ideas to keep in mind for troubleshooting. Number one, check if the VLAN has the correct ports assigned to it. If you accidentally assign the wrong port or miss a port in your VLAN configuration, that device won't be able to communicate with another device in the same VLAN. So make sure your VLAN ports are correctly assigned. So also check your trunking configuration. Make sure that the correct ports are set to trunking mode, and make sure you use 802.1q. That's very important. Not using this will actually cause the trunking to not work. So also make sure all devices in the same VLAN are in the same subnet. As I discussed before, if your IP addressing is wrong, like if you have computers in the same VLAN in different subnets, then these devices are not going to be able to communicate with one another. So finally, remember that the ping command takes a few tries to work due to the ARP process. So this is after you fix stuff and you are checking your configuration. You may get like timeout errors still. Please try it a couple of times. It takes a little while for ARP to take place. So that's why when you fix your configurations, even if it's correct, you still may get ping errors. So here's a little lab I built. So we basically have two virtual LANs we're going to build here. We have VLAN 10 with computers Mario, Luigi, and Peach, and then we have VLAN 20 with Wario and Waluigi. It's a nice pop culture reference here. So anyway, so this is a multi-switch VLAN configuration, and we need to account for that with trunking. So I will tell you this: I've already configured everything on switch 2, IOU2. So we're going to go ahead and move on to IOU1. So also all the PCs have their IP addresses configured. I can actually show you this. Oops. So PC Mario here can ping 192, or sorry, 10.0.0.3, which is Wario's address. So yeah. So our ping and IP addresses are working. Now, when we make this configuration, I'll need to change the IP addresses of Wario and Waluigi. But so for our scenario here, this is like what would happen in a typical network. So in like a production network, you will most likely encounter a LAN configuration where or network configuration where the company wants to keep certain computers from contacting others. Like for example, if you have research and development, you really don't want like the sales and marketing team or certain other users within the organization to access that information on our research and development computers. So VLANs are an option here because data or devices in the same VLAN or one VLAN cannot communicate to devices in another VLAN, assuming routing is not used. And that's how a typical network would actually set this stuff up. So for our scenario, we don't want Wario and Waluigi to communicate with Mario, Luigi, and Peach. So to do this, we can create VLANs. So let's go ahead and conf t. So I actually increased the size of the terminal so for better visibility. So the first thing we need to do is assign VLAN or assign ports to a certain VLAN. We can also create the VLAN before we do that. So if we go back to my command guide here, here's some steps you need to go through. First step you need to do is create the VLAN and then assign the interfaces to the VLAN. You can actually assign the interfaces to a VLAN without creating it. I can actually show you this right here. Excuse me. So int range E0 to 0 to E0/3. So this is all the E00 ports. Whoops. Let me see here. 0 to 3. So that's how you do the range. I'm sorry. I didn't intend on this, but this could be a little demonstration of how to type in the range command. So you don't put like the 0 and the slash or the E. Just put the number, the number at the end. So what we're going to do with these ports, they're for Mario and Luigi VLAN 10. So what we want to do is make them access ports. So let's go back to my command guide. So switch port access VLAN, or actually we need to do this up here first. So switch port mode access. I apologize for that. So the first thing you want to do is select the range of ports that you're going to be configuring. Then type switch port, port mode access. There. My apologies. Now we're excuse me. We're now configuring or assigning these ports to a specific VLAN. So the command is switch port access VLAN 10. So if you see here, I didn't create the VLAN prior to typing these commands. So we get a message here saying access VLAN does not exist, creating VLAN 10. So we can type end, copy our UST for saving, and then show VLAN brief. So this show VLAN command is basically lets you see which ports are assigned to a VLAN, whether these VLANs are up. So you can see here the VLAN we created, VLAN 10, and the ports assigned to it, which, let's go back here. E00 and E01 are connected to the Mario and Luigi computers, and we need them to be in VLAN 10. And you can see here VLAN 10 active, and those ports are in it. So we need to go back to CompT, and now we need to do the same for the other ports here, for the Wario and Waluigi computer. So int range, so you can actually use ran for short, E1023. So the first step is to make the port switch, or put them in access mode. So switch port mode access, switch port access VLAN 20. So we get the same message, end, we can save, show VLAN brief. We'll move this out, and you can see right here VLAN 20 got those ports. Now let's try something here. Let me get the computer out. Okay. So now Mario and Luigi computers are VLAN 10, but the Wario and Waluigi ones are VLAN 20. So they're different VLANs. Let's see if they can communicate with one another. Well, let's actually try that same ping command. That's the Wario computer. So you can see here, it's not reachable. So the reason that is because these computers are in different VLANs. They're basically in different LANs, and should be in different subnets, but we won't deal with that right now. But we also want the Mario and Luigi computer to be able to contact the Peach computer. So let's try that. Ping 10.0.0.5. We can. So it actually can without trunking. I should have realized that. I apologize. But if we had like a VLAN 20 computer over here, if we had multiple VLANs on the switch, there would probably be a problem, and that's why we need trunking. So for the sake of completeness, I'm going to configure the trunking anyway. But when you work on your lab, do note that the computer connections won't work because all the switches, I think it's 2 switches, will have multiple VLANs, and therefore they won't be able to communicate with each other. The computers in the same VLANs won't be able to communicate with each other unless you configure trunking. So let's go ahead and do that. So the configured trunking, we look at my command guide. Basically, you configure trunking information or interfaces with CompT. Type in the interface. You type these 2 commands, and that's really all there is to it. So CompT, so int e2/0. If you look here, the port that connects the 2 computers is e2/0. So the Ethernet interface we're going to configure here. Oops. Apologies for that. So switch port trunk encapsulation .1q. So switch port mode trunk. And that's all there is to it. Okay, let's try the ping again to make sure it works. So the Peach computer can still communicate with Mario and Luigi. So that's basically all there is to VLANs. So as a little recap, so basically you first assign your ports connecting to computers as access ports. You then assign those access ports to the VLANs they need to be assigned to, and then you create the trunk. You create the trunk on the cables cables that connect to the switches together. And that's really all there is to VLANs. Thank you for watching this video. If you have any questions, please let me know. Thanks again, and have a good day.